Good evening, everyone. How are you all doing tonight? Oh, they changed it. Something like that. Good. I turned down the music. Let's see. Can everyone hear me? It seems so. That's good. My desk is a giant mess. And I haven't even been here much the past few weeks, so, you know. No music today. There is music. Are you not hearing the music? No, well, okay, now there is no music. There it is. Wait, you're not hearing music? I'm hearing the music just like normal. It's a bit low, but... I'm waiting to hear back on the music stuff. I like some music in the background for when I'm doing things and you guys have to wait. Oh, Willem is here. Nice. There is soft music. Yes, that's good. Did I turn it down too much? I don't know. Let's leave it at that. There. I can't really... Let me see if I can hear it myself. Yeah. Now I don't know what I'm hearing. Okay. Why would it be softer than normal? That's odd. Good evening, Jammy DJ. Welcome to the pre-stream where we're trying to figure out why my music has gone soft. That sounds wrong. No, this all looks good. Not enough pink LEDs. What do you mean? There is so many pink LEDs. Did anything change in regard to the music? Nope. No clue. We're going to leave the music as is. If it's low, it's better than it's when it's too loud. So, oh, let's put the thermal camera on the charger. You hear it. Okay, good. This new thermal camera has quick charging. It actually asks for, let's see, 12.1 volts at 1.4 amps. So that's quite decent. What happened to the lighting? What did happen to the lighting? Is there anything off? I mean, I'm here. Can you see me? We still have outside lights. Maybe that's it. Medved is here. Oh, and Kiwi Pepsi Cola. Good morning, all. It's a nice 2 degrees here in southern Canterbury, New Zealand. Whoa. It's like 28 degrees here. I am in a non-air-conditioned garage. So, yes. The shelf lighting. It's on. It's working. What are all these changes? I don't stream for 2 weeks and suddenly everything's changed. 32C outside. Well, not anymore. Then I'd die in here. Then it's like 36. No, the shelf lighting and everything is working. Same temperature here, 28. Yeah, it was white. Didn't see it. Oh, okay. Okay. It randomly changes color. It's like a script in Home Assistant that does it randomly, or in ESP Home, so I have no idea what color it's going to become. Where's the real Quindor? Yes, maybe they hit him. Well, speaking of, Today we have an assortment of drinks. It is a fallen can of Coke Vanilla, Coke Zero Vanilla, and some Fanta Zero Sugar. And to amp everything up, we're going to drink the Coke first. Well, you can already see some stuff I've been playing with. Let's see if I can still open this can. Yes. Well, not really. This can fell on the ground, so now it's not, you know. But we have tools. We can stab it with like a screwdriver, no problem. There. Some Coke on the screwdriver, always good. Anti-rust. Oh, nope. Don't do that. Oh, my face cam moved. Yeah, no, we tried mixing like 2 years ago or something like that, and I don't know, it didn't turn out great. So we're not mixing today. And we don't need ultras today either. We're just going to drink straight Coca-Cola vanilla. Now it's a Quin Coke. Well, it's a screwdriver Coke, I guess. I had the windows and the doors open a few days ago when I was working here because it was so damn hot. And now there's all kinds of fluff and animals and insects and, well, not animals, insects and all kinds of crap in here. I got some spider webs on my desk for some reason. Carbonated. No. Yeah, no, I'm not drinking Pepsi, sorry. So today first, while it's still light, we're going to be testing Diff-Power, the newest prototypes, and see if we can break it. That's always good, right? Trying to break stuff. I need to disconnect something here. And once it becomes a little bit more dark outside, we're going to pivot that into trying to get some LED strip in a silicone sleeve, and then seeing how well the diffusion looks. I know I can't talk about it. It's okay. It's my own rules. I can break my own rules. Magic smoke time, possibly, yes. We're going to try and plug and unplug Diff-Power like a bunch of times. And doing it erroneously. And, you know, maybe we could even hook up some kind of deliberate short circuit. And then see what happens. Well, if I'm in the main house, we have floor cooling, and that works quite well. So then it's like 23, 24 degrees. That's fine. And in the bedroom, we have air conditioning. I can recommend that to everyone. Dutch maker, the power diff or Diff-Power runs at 55 volt even. Oh, now I have two chats. That's interesting. The new house. We actually sat with the architect again today, and things are progressing a bit slow, but they are progressing. And we hope to submit the plans to the municipality, I think it's called, in hopefully next week or something like that. Airco is on 24/7 last days. Yeah, well, for us in the bedroom, but yeah. The rest is cooled by the heat pump outside with the floor cooling. But the higher you go in the house, and our bedroom is in the attic, the less it works. Oh, nice, Greg. That's interesting. Cool. Yeah, I didn't stream or have videos for like 2 weeks. I was busy with a lot of other stuff, and then more stuff happened that I had to deal with, and yeah, so there was a lot of things going on. Yeah, so I just didn't have the time or the energy, but that is all resolved now. So, oh, I think I found the spider that made the cobwebs on my desk. Let's remove him. He's living inside of my speaker. Interesting. There's some difference in prices, yeah, but we're still negotiating prices, so. The new ESP32s are a little bit delayed. I submitted a new prototype today, so hopefully that resolves some of the last issues I was having with it. So yeah, they are a bit delayed. I'm gonna try and get this spider to vacate the premises. Where are you, little spider? Sorry, I'm just blocking this camera. No, I'm not gonna kill it. I'm gonna put it on this paper and then dump it outside. Where are you, little spider? It disappeared. That's never good. Nope. Okay, I don't know where it is. It was there, and now it's not there. Did it go inside of the speaker? You have a house spider for years in the hall. Well, they do catch mosquitoes and stuff like that, so. The cobwebs and the cob LEDs. I live in the Netherlands, so we don't have any dangerous insects here, so, yeah. Oh, something we could do in the pre-stream, actually. That'd be fun. I harassed Guide IR again. These guys, Guide IR, I harassed them, and I got new firmware, because they make new firmware, you just don't get it. I'm like, what? Yes, when there's new firmware, you have to ask for it. Okay, but then how do I know if there's new firmware? No reply. And then I was like, okay, but then if there is new firmware, can I get it? Yes, there is new firmware, you can ask for it. Okay, I'm asking for the new firmware. Why you want the new firmware? Because it's new firmware, you fixed bugs, and I'm having issues with Wi-Fi and stuff? Oh. Can you make video of issues? Well, I sent them some links of the live streams where I was ranting about it not connecting, and they were like, oh, okay, here is new firmware. And then they OTA push it to the device. So you enable Wi-Fi. Okay, it connects. And then in general there is check updates. And then you can say OTA upgrade. And then you'd think, like, okay, if there is new firmware, it would show up here. No. They have to enable each firmware per device. So you have to just randomly email them a few times a year if there's new firmware. And then you have to convince them to give you the new firmware. And then they make it so that your serial number can actually OTA it. It's so... Why? Stupid. Okay, so now let me open Thermo Tools. Let's see if that has an update. You will own nothing and be happy. Oh, there is more updates. Okay, let's update this too. Fine, let's go. Downloading updates. Yes, good. Yeah, but it's just, I mean, if you make improved versions, just share the versions. Just share the versions. I mean, how am I supposed to guess when there's an update or not? What? Yeah, I always update everything before the stream. I also updated the Raiden software, and now I'm updating Thermo Tools. So let's see. Oh, yes. Okay. Next. I agree. Sure. Let's go. No, I'm actually hoping, because I haven't tested it yet, that it works better now. So, Thermo Tools. Okay. There it is. Video. Connect. LAN. Oh, that I don't think that's the right IP address. At 10.24.1.128. Okay. Okay. Confirm. Let's see if it connects. I know you can't see it. Sorry. Failed to connect the device. Aw. I was so hoping this firmware update would do it. Let's think. No, failed to connect the device. Okay, let's do our little clicky things that we go in here, and we also enable RTSP. Let's see if that does anything. Oh, it did it. Oh, I mean, it's a lot better than it has been. Wait, I need to resize the window and then zoom in. So let's enable the thermal camera. Okay, now I need to fix this. Okay. For some reason the font went small again, so now I need to fix the font. I think we can do that over here. Font size, I don't know, 30. Go there. Okay. Yeah, so can we now thermal image stuff? Let's take the macro lens off. Yeah. Okay, that works. You can see the camera and see the camera up there. Camera is running hot, 40 degrees. And this one is also around 40 degrees. And my chargers that are powering the cameras. And do we have any electronics? Oh, the Raiden is on. The power supply over there. It's a little bit warm. The LED bars are warm. How warm are the LED bars? 40 degrees. That's also fine. No problems there. 40 degrees. That one. Oh, my PoE switch and my SFPs. How warm are the SFPs? The SFPs are 56 degrees. Okay. That's okay. They're copper at 10 gigabit SFPs. Pointed at myself, sure. Where am I? I'm a bit warm, 36 degrees. So yeah, okay. We at least have a working one. Maybe I can put it up here. A little bit bigger there. Okay. That's a bit too big. Okay, well, we've well exited the pre-stream, and as I said, while it's still light outside, which is currently the case, we're going to hook up the latest Diff-Power prototypes, and we're going to, plug and unplug until it breaks. It's always good, isn't it? Did you get release notes? No. So I already was playing with it this week. I got new prototypes for everything. So for the Sender 1, for the... Well, this one's screwed together. Let's see, this one. For the receiver... what did I call it again? The receiver dig medium. So this is for digital LED strip, either 5, 12, or 24 volt, depending on the buck converter you mount on top of it. This is the version with, or this is the same one, but then with the buck converter mounted on top of it. So the buck converter just connects here in these terminals. We have our RJ45 socket, and then we have our digital output. And that's what we'll be starting with. But I also have an analog board prepared. So this has 5-channel analog output, so RGB and then dual white. RJ45 for the input, the buck converter socket again, because you connect this buck converter and then you can mount it on top of there. But this one I've added a dig to analog plus output. So if you wanted to chain more devices off of this one and its buck converter, you could actually do that. So you have Diff-Power coming in, but dig to analog plus going out to the next one, basically. I haven't tested that yet, but in theory that works. But let's test the digital one first today. I selected some LED strip I haven't used yet. Now the thing is how I constructed it to make it as small as possible. The buck converter terminals are underneath the buck converter, so you can't reach that. But you screw it in and then you put the buck converter on top, so I don't think that's an issue. And then this, you know, the Ethernet port, or the RJ45 port I should say, you can still easily reach and plug in and do stuff. But these, the output terminals, I left slightly outside of the buck converter so that we can just screw things in. And it has a nice labeling here already so that you can see which is which. So VCC, data, ground, and some status LEDs. So let's do that. Now I always need to watch out with these pigtails if the colors are actually correct, but I think they are. Yeah, on this one they are. Is that for the case power fails? Or at least there's daylight? What do you mean? So let's see. We have data. And then we have backup data and ground. We're just going to combine those into ground. No, it's just that the silicone sleeving we're going to be using is a black variant. I can show it real quick. It's this stuff. So it is basically black on the outside and black on the underside. There is some diffusing material on the inside. But basically when it's off and dark, I think it'll just look, well, black. And since the QuinLED COB strips are quite bright, I'm thinking that's going to give a really, really nice effect. But we'll take a look at that later. Yeah, it's 2 centimeters wide. I think it's also 2 centimeters thick. But that's a topic for, you know, in an hour or so. Yes, the idea is to have 3D printable housings for this. I'm not quite sure how that's going to work yet, because you need the buck converter on top. What are we looking at? Okay, let's put this over here. But, you know, we can still maybe design some kind of housing where the top is just open and this sits on top or something like that. I don't know yet. Okay. So, we take some Ethernet wiring. So this is 12 volt WS2815, so we need 12 volt. So I have mounted a 12 volt buck converter, so it's 36 to 48. We're actually using 55 volt coming in, and then 12 volt up to 7 amps out. Now we're not going to be able to do that, I think. No, it's 84 watts. Yeah, we're going to be able to do about 100 watts effectively. So yeah, we're going to get pretty close. And for this today, I prepared the Raiden. So let's see if that works. How does that software work again? Oh right, I think I only took this part. This is wrong. Still wrong. Hold on. Okay, yeah. Yeah, I guess we could look at the whole panel, but then my desk space is getting very limited. I'm gonna move this here and a bit smaller. We're only gonna use that a little bit. So, okay, let's make this smaller too. Maybe we can do it like that. Not sure that's still readable, but I think that's going to be it. Yeah, the QuinLED COB, yeah, they're very bright. And so that's why I think it'll work really nicely in that black diffuser, because that is going to cost you a lot of light. But then if you start with a lot of light, you know. Okay, so on the power supply, I have it set to 55 volt and 5 amps. And what we've done, we've connected the 55 volt with 5 amps, but there is a 2 amp fuse here. So into the Diff-Power sender 1. And what that does, it makes 5 volt on board. So I have a USB-C connection or a 2-pin output of 5 volt, which then goes to the Dig Next 2 to power the Dig Next 2 with 5 volts. So you don't need a separate power supply. And then I thought, okay, we could use the output ports, of course, but we could also use the QEXP connector. So we have this little connector here on the Dig Next 2, which exposes some extra pins. And you get the pigtail for that with the controller. And it comes with some DuPont style wiring. And I've wired the ground and 2 data signals up to the sender board. One data signal is for the LED data, and the other data signal is for the on-off toggle. So you can use it as a relay so that it actually turns off power, or at least a 55 volt, to the remote board, so you can actually, well, centrally turn it off, right? So it doesn't use power. So let's turn that on. Nope. Okay, I need to do it in the software, I think. On. Yeah, okay, so now it's outputting 55 volt at 0.55 watts because it's only this board, 55 volt coming in, and then there is 5 volt going out. We can probably see something warming up now. Yeah, so this is the conversion IC that I use to make 5 volt from the 55 volt coming in. We have some resistors here for the RS485, and the rest is still off. Or actually, it turned it on already because I configured the software. Now I need to look up the IP address. I think it connected to Wi-Fi. Yeah, 10.24.1.1. Okay, hold on. Yeah, so if I, in the software, turn it off, you see that the enable LED on the board turns off. Okay, good. So let's keep that off right now. And let's plug this guy in. So you just have a UTP cable. This one's 20 meters, 25 meters, something like that. Okay, now we see a different LED light up. That is the remote board detection LED. So it found that it has a remote board connected. So if I remove that, it doesn't have that. But it's still off because, well, we haven't done the enable. And it needs the enable plus remote detected to turn on the output, basically. So I need to go into config. I need to change the LED hardware. Oh, it might actually be set okay. We'll give it a try. Back. Okay, let's power it on. So now this one turns on, that one is on, and then after about 1.5 seconds, it'll also turn on the output. And as you can see, that worked. So if I do some blends or something like that, or Aurora, yeah, it starts doing stuff. Let's see, what pattern can we do that's visible well on camera? Okay, that's pretty visible on camera, I'd say. That's good. So, yeah, the system as it's designed, we need two things to be happening at the same time. We need the enable, because if I don't do the enable, you'll see that the output turns off. So the output LED is over here. Remote also disconnects because I have a sort of drain on there so that it drains the power immediately when it's off. So now we currently only have a remote, but if I enable the power again, then the LED strip turns on. Same thing, if I remove the RJ45 over here, the remote detect is off, so the output is also off. Right? So that's basically the idea. That gives you a lot of flexibility to also be able to use it as a relay or built-in relay, really, so that if you don't want it powered, you're not going to turn this light on for the next 12 hours or whatever. Yeah, we're going to use a pink LED for the output enable. Hey there, Philip. Oh, you've tested them before and they work really well with bright LEDs. Yeah, we're going to see that in a bit. Yeah, so the idea is that you can now hot plug this. I'd still prefer it if you didn't hot plug it. But in theory, if we now plug this in, there is a delay built in of about 1.5 seconds before it turns on the power. So there's a low voltage 5 volt running to do the remote board detect and things like that. And the 55 volt, which we're currently sending, we're doing 9.35 watts. Whoa. So if I up this, yeah, now we're doing 13 watts, and now we're doing 6 watts. Yeah, that works well. Yeah, so there's a remote relay built in, so that especially if you want to use one of my bigger boards where we have like 6 or 8 outputs or something like that, you could have a central 1500 watt, I don't know, or 800 watt power supply, and you could still turn off the remote boards, or at least mostly turn it off. There's still some very low current 5 volt running, which is all protected and blah blah blah. But yeah, at least there's no current draw from the LEDs anymore, because those will actually be physically turned off, right? So if I do this, let's see what our power usage does. Oh, our power usage is now 0. Oh, okay. It's not really 0, but it's below what my bench power supply can measure. Yeah. So, that. Okay, let's turn that on again. But that means that if you have lots of digital LEDs connected to a single power board with multiple outputs, when they're off, you can either set them to 0 brightness, so you don't see anything, but you can quickly turn it on, or you can disable the enable, and then it'll actually power down the hardware. Now, let's see on here how things are going. This is 43 degrees. That's not bad, since it's 26 or 28 degrees in here. We have our termination resistors. There's probably one resistor here that's warm. That's good. I did change these resistors. So that's now 40 degrees. That's good. And this board has a new mechanism that if I turn things off, it'll actually drain the current that's still in the circuit, so that if you turn it off and turn it on very quickly, it basically doesn't do that, and there's no residual current from the capacitors and things like that. So if I put this over here like that, and I now turn it off, you can quickly see a spike in temperature. There, see it? That is a circuit that turns on for a few seconds when you turn it off to basically instantly drain all power, so that it's, well, instant off. And if I turn it on, you see a slight inrush, but it's also not too bad. We can do that again. So outrush and inrush. But, either or both of them very well controlled, and they shouldn't cause any issues, even if you did that 1,000 times or whatever. Yeah. Yeah, temperatures on the board look pretty good. This one is connected to the 55 volt, so that's going to get a little bit warm, but that's an 0805 now, I believe, or an 0603, so that's fine. These are the termination resistors that's expected. Yeah, that's all good. So before we had issues that if we kept plugging this, it would break. You know, it would destroy the RS-485 chip, or other stuff would blow up. Yeah. Yeah, right. So I did that so that if you do this, as you can see, it's basically instant off. And that means that if you plug it in again, whatever voltage was running, like the 55 volt, that's basically immediately gone. So the idea today was, we're just going to try and plug this in. Let's do it correctly a few times and see if it stays working. I would expect so, but... I did change the protection schema. There's now CDACtors and TVSs and all kinds of other crap in there. And also a thing that's interesting is if the turn on delay is now fairly consistent. Because before it could vary a lot. But now it should be more consistent, I think. So for the next half hour, I'm just going to sit here plugging this thing. Welcome to the live stream. It's still alive. It's still alive. But will with 36 and 48 volt LEDs. So this is not designed for 48 volt. Basically, we're sending 55 volt. And then we're going to use a buck converter at the end to convert it to the voltage we need for the LEDs. In this case, we're doing 12 volt, but I also have like, I don't know, a 5 volt buck converter here. Or, I haven't unpacked this one yet. Did they make a notch? Let's hope so. No. Oh. Eh. Or a 24 volt. Right, so you can choose whatever voltage you need on the output. There is a 36 volt version of these buck converters in the same form factor. You can already see that this is 84 watts, so in theory you can run that to the maximum. This is 144 watt, that is above the maximum of the system. The maximum is about 2.25 amps at 55 volt, but I'd say effectively like 100 watts. But yeah, you can. I think you can still stretch it to 36 volts, but above that, depending on the cable and the length. So let's see how much voltage drop we're getting. So the LEDs on the outputs aren't always on. If you see now, there's a green one and a yellow one. And now there's none. Right? And if you plug it in, it'll show a remote detected LED. And then the yellow one is that the output is enabled LED. Hold on. Let's see if I can connect to my multimeter. I can. Let's enable the multimeter. There. Okay. So currently with our, how many watts are we using? 7 watts. Well, that's not a lot. Oh, I have a screwed on buck converter. So our output is going to be pretty clear, right? 12 volt, because that's coming out of the buck converter. I'll need to unscrew this, because otherwise I can't reach those terminals. Okay, let's get those screws out of the way. Okay, so the idea also when you construct this, you screw it in like this, and then you do it like that. So yeah. Our input voltage is 53.8. So even though we're only using a few watts, we've already lost 2 volts. Now, that is because it's running through diodes and fuses and this really thin but long Ethernet cable, or yeah, so that's going to always cause some voltage drop. But because we're buck converting, that's not a problem. We can raise this. Let's see what happens. Yeah, if we have more output, we have more voltage drop. It's amazing. Let's go to solid. So now we're at solid orange. That is 20 watts. So now we're at 52.7. Or if we go to red, oh, this is WS2815. So this is already the maximum draw, actually. Even white is not going to draw anymore. No. Okay. Aw, too bad, Greg. I don't know. Let's go to glitter. Sure. All good. Let's go to gradient. Whoa. Yeah, so depending on the usage, you will get more or less voltage drop. But as long as you stay above, with these buck converters, about 30 volts, so you can lose 25 volts, you're going to be fine. So in practice, that means you can get about 100 watts at 100 meters away, right? And if you don't need the 100 meters, you could maybe get like 110 watts or something like that. But that's why I'm calling it 100 watts. It's 2.25 amps times 55. So you actually have a little bit more, but you need to calculate a little bit of headroom for the voltage drop over the cable. And I don't know what kind of Ethernet cable you're going to use. If you're going to use this, what is it, 28 gauge? Yeah, you're going to get a lot of voltage drop. But if you're going to use 23 gauge, you're going to get a lot less. So your props that are 100 meters away, if you use like normal Cat5e, that's 24 gauge, maybe 26 gauge, you're going to get about 100 watts effectively at 100 meters. So, yeah. Let's see. Why are the RJ... Okay, we did that. 3 to 5 amps. No. 120 watts, or 100 watts at 5 volts is 20 amps. At 12 volt is about 8 amps or something like that. And at 24 volt, it's about 4-ish amps. So it really depends on the voltage you need for the output. So this medium board, as I call it, is well suited for 12 and 24 volts. I will introduce a large board at some point. I've showed it off really like years ago already. But those will use this style buck converter. And well, this one is a 24 volt, but if you get them in 5 volt, you can get them with 5 volt 20 amp output. Yeah, and then you need a larger board for this buck converter, but then you can also get 20 amps of 5 volt at 100 meters distance, right? While we're talking, I should be plugging and unplugging and doing it the wrong way. Like, oh, it was still, oh no, I did it. Okay, do I want to plug it in? No, I don't remember. Should I plug it in now? Is the power on or off? When are we gonna, okay. That still works. So maybe I should try and get it out. 1, 2, now. No, okay. 1, 2, now. Okay, no. 1, 2, right now. 1, 2, now. Maybe 1, 2, now. 1, 2, okay. No, it still works. Okay, let's see some more questions. What will happen if people connect buck wrong way, like input-output switched or polarity reversed? That I haven't tried yet. Well, I have enough boards to see what would happen. We can try that in a minute. I'm just going to stay plugging it for a while to see if it breaks. And otherwise we can try that. Live stream... Oh, okay. Let me write that down. That's a fun test. Wire buck converter wrong way around. I think the buck converter will just die because it's going to get 55 amps. But the feeding lines are connected with 3 times 750 milliamp fuses, so 2.25 amps in total. So likely those will activate at some point if it's a dead short, right? I was going to say, did I break it? No. Okay, I'm just going to keep on plugging. La 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 la. Okay, more questions. Many uses for this system. Awesome, awesome. Yeah, this isn't to make it cheaper, but this is to make it more convenient. 100 watts, yes. Yeah, 100 watts should be effectively possible, yeah. Looks very good, very impressive. Thank you, Jordi. That's really great. Does the buck converter fit under the board as well as above it? I have no idea. You asked very interesting questions. Let's screw it into this one. Let's see. That's actually a great question, because then... I like this question. I didn't think of that. You stare at this for years. I've been working on this for years. Don't ask. And then I never think of these things. So when above 4 amps, these outputs are also used to inject elsewhere on the LED strip. Well, especially in the 5 volt situation, you have 20 amps available. So then you could use that for power injections, yes. For 24 volts, if you only have about 4 amps available, yeah, it doesn't make too much sense, right? Because you only have 4 amps. What you could, however, do is use a second port on one of the bigger output versions that will come in the future. To then, you know, run a second Ethernet cable, which will then also carry 100 watts. Yeah. It's not going to make it cheaper, but it might make it easier. Well, these boards are, as I call it, phase 1. We're going to do it like Marvel, right? We're going to have phases. So phase 1, is this connected? Yeah. Is what you see here. So we have, plus this one. We will have a sender one, and then we'll have a digital medium receiver board and a analog medium endpoint receiver board. In the future, however, and there is already a prototype, I also want to build versions which have an integrated buck converter, right? So this has the power circuitry that is now in this black little box here, integrated on the board. And this was an analog version, but the digital version can even be smaller. Yeah, so it'll have integrated buck converter. But that's what I call phase 2, because I did an experiment because I was excited, and this one works. That's not the problem, but it can only do like 0.75 amps of output, and otherwise it gets too warm. At 24 volt, that's still pretty decent. It has a selector between 24 and 5 volt. But yeah, phase 2 will have multi-output boards and smaller integrated boards, right? But that's, you know, these are going to be more expensive again because it needs expensive ICs to be able to convert that kind of power. But yeah, can the buck converter go on the bottom? I guess. I mean, the problem is you have these. Wait. The problem is you're going to have these pins here. So that's something to take into account. This is just a hard shell, so that doesn't matter. I guess we could mount it like this. Huh. It's actually not too bad. I mean, this is a hard shell, so the pins don't matter. And this way, we could make a case for it. I could even make the board smaller. Huh. Because then we don't need this exact... Well, we still need the exact shape. But this could, for the... for this part, we could move it back. I think I can squeeze it on there, basically. Yeah, I think the multi-phase sender boards are going to be in phase 2. I wanted to do everything at the same time, right? But it's just too much. So I think that we're going to move that to a second phase. When you seem skeptical, what? No, skeptical and critical questions are good. No worries about that. Yeah, so there is going to be some heat, but I mean, this has been running with 16 watts for a while now. Let's see, how warm is it? It is 35 degrees. Oh, you don't have a center point. What? I updated the software and turned off the center point. Hold on. Is that the center point? Yeah. Okay. So this is about 35, 36 degrees. I don't know which side gets warmer, though. Okay, the bottom side definitely gets warmer. Okay, but then do the same standoffs fit? Okay, we're going to just leave this here. Because this is, in theory, still just as big. Right? So these are 15 millimeter standoffs. Because that's what I need to clear the terminals and everything else. Need more power. Yeah, but at some point the Ethernet wiring is going to get too warm for comfort, right? You could push more power. But I don't... Yeah, okay. So my 15 millimeter standoffs are not going to work. Because we're going to need about 20 to do it that way. I probably have those, though. Let's mark it up. Let's see. What is this? 20 millimeters. Okay. Does 20 work? Let's see. Yeah, and then it's slightly above the edge. That's good. Let's get some screws. These are 6 millimeter screws. I'd include 8 millimeter ones. So the idea is that the buck converter, I'm not sure I will sell it, or maybe I will offer it, but you can probably get it cheaper on AliExpress yourself. Especially because of all the shipping involved and things like that. But yeah. Oh, I didn't put those in the link. Yeah, I have some links. Hold on. This is going to make it harder to screw in, though. I guess you could use some pliers to hold it. I mean, the twisting of the cables, that's okay. That's fine. Okay. In theory, that still fits. I mean, I don't know why it would be different. It's not really sitting on there great because of the protruding solder joints. And over here, of course, it protrudes outwards, so those aren't stuck like that. But if I'd make the board smaller, it would basically be the same shape. So Medved, for my strips, for a 5 meter, we calculate with 50% white. That is about 100 watts. So you need a 24 volt 4 amp or 5 amp buck converter, and then you can run one strip. .21 millimeter standoffs, yeah. I mean, we can get all the standoffs we want. That's not a problem. Yeah, this might actually be a nicer construction. Now, there is no feet, but you could also, yeah, You couldn't really screw feet on there. I can think about it. I mean, the idea was that I make a case. Yeah. I make a case where this is all enclosed and the buck converter sits on top, but let's see if it makes any difference in regards to size. I don't think so. Let's screw it into the working one so that if the screw drops, everything dies. So far it didn't die yet. Yeah, so this is perfectly spaced for these terminals, right? So you have a little bit of a gap with the capacitors and the terminals and everything. But size-wise, yeah, I don't think it matters too much. No windows. Now is not a good time to set things up. What are you talking about? No, these are still in development. I hope to release them this year, but yeah. But case-wise, it would make it easier, huh? One case for all the flavors. Well, one case for a digital board, one case for an analog board, because this has somewhat the same shape, but it's a bit bigger than the digital one, as you can see here. So it's basically the same shape, but I had to try and squeeze some stuff on there. So the general shape is the same, but the lip is slightly different. So it's mostly the same, but not exactly the same, because I wanted to have the fuse here. That was a test, but the problem is the analog board, as you can see, yeah, there's just too much stuff on there. I can't really squeeze more on there, right? So this couldn't shrink in size because there's just no room. Yeah, for access-wise, this still has access to the outputs and the input, right? So it doesn't really bring you much to do it this way, except that it is a bit cleaner, sure. And the digital board could shrink, but the analog board, I don't think so. Because, yeah, I mean, you can see how densely populated it is over here. There is no room to squeeze that in there. And the idea also was, that's why it has the mounting holes on the side here, is that if you do it this way, you can use these either for feet or for mounting it down, right? And if you do it this way, there is no real way to mount this down anymore. But, I mean, in the end, I'm going to sell you the boards. And if you want to mount it this way or this way, that's all fine with me. Yeah. So, and it is interesting. It is interesting. But even the analog boards, these terminals will stay... Oh, I have one here. Right, so the output terminals will stay exposed. These terminals you only need to connect once, and you can easily reach the RJ45. So yeah, same deal. Yeah, you can indeed. you need a double mill. One you screw in here and one you screw down, I guess. Yeah, you could build it up like that. That is true. But it's a bit less convenient than just having the mounting holes there. But yeah. I mean, as I said, I'm going to sell you the board. And how you decide to use and mount it, well, that's up to you, right? I'm not sure I will adapt the boards to make them smaller. Yeah. I need to think about that one. Oh, I need these. Because with a slightly bigger board, this stays possible. But I get making it smaller like this. For the digital one, we could do that, but I don't know. The fuse location here, that was a test. I might also do that for the digital one. Not sure yet. I have to see if I can make that fit and put the LEDs in a logical place. We're still not breaking this thing. Let's try plugging and unplugging this side. So the discharge circuit that I made, you can see it on the purple LED there. That is the 55 volt, and it's currently still glowing slightly with 5 volt on there. I'm not sure I'm going to correct that or not. We'll see. But if when I disconnect it, you can see that it's basically gone instantly. Takes like half a second, or not even 250 milliseconds. So we're just gonna keep unplugging it for a bit. So currently the drain circuit is, I believe, 8 seconds or 6 seconds. I was thinking of lowering that down to like 2 or 3 seconds, because then it's already plenty drained. But it's also interesting because now it doesn't remote detect because the drain circuit is still active. So this actually is a extra hot plugging protection if you do it quickly enough, because when the drain circuit is still on, it doesn't detect the remote, so the output is always off, right? I'm just gonna, keep on plugging, la 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 la. Okay. So if I now disconnect it and then connect it, it doesn't turn on because of the drain circuit, and then it turns on. But that also happens if I do it logically. So now it's off because the remote detect is off, but that also means the enable is off, but that also means you can't quickly disable or enable it because the drain circuit, currently the drain circuit's still active. Now it's done, and then it comes back. You'll get it to break. Now I'm wondering if we should keep it that way or not. I think I'll lower the duration of the drain circuit a little bit so you can turn it on and off quicker. Then again, if you want to turn it on and off quickly, just don't turn off the enable. Right, so if we just lower the brightness to... Oh wait, no, I need to set it to solid and then black. If we just do that, it's still on, right? And we can instantly turn it on again. You just don't disable it. But if you do disable it, yeah, it takes a few seconds before you can enable it again. But is that a problem? I don't know. What do you guys think? Is that a problem? I mean, if you need quick on-off, you just leave it on. And for the periods you don't, like during the day or whatever, you just turn it off completely with the disable. Yeah, I might lower it a little bit, because right now it's pretty long. Maybe to half that time, right? Because then when you're doing this, did I plug it in right? Okay. The enable is just a GPIO, so it sends a 1 or a 0. You can override it with the jumper. But yeah, this is just a relay configured in WLED right now. Well, when you turn on a light, I can imagine you might be bothered by that, but let's simulate that. Okay, right now it's off. Let's see, remote detect. So normally if a light is off in your house or whatever, it would be in this state. Remote would be detected, enable would be off. Okay, now I hit the power button in WLED. There. That is a built-in deliberate delay to prevent the hot plugging causing issues, right? Yeah, but let's say it's your bathroom light, okay? It's going to be in this state, okay? And I hit power. Is that too long? I don't know. It's 1.5 seconds, because that's basically what I programmed the delay to be. Except if you just turned it off, it would be longer. For main source of light, yes, too long. Okay. Yeah, then you need to have it on standby, so not disable it, basically. I don't know about that, Marcus1. I'm going to use it for my main lighting for sure. But then again, all my lights run on sensors or timers, so I expect a 1 to 2 second delay. That's fine. Okay, well, too long. Okay. Well, if that's too long for certain lights, then you just don't disable them, and then it's instant, because then it's always powered, right? But if you have lots of digital LEDs connected, but then you could maybe like make a schedule in Home Assistant or whatever, like, okay, keep all the disables off during the day and keep all the enables on during the night, so that when you want to change the light output value, you can easily do that. Can it be configurable? No, it's a hardware feature. You can configure it by changing this capacitor here. Sure, okay. Yeah, I don't know how to override that. I need to think if I can override that. I'm not quite sure. How about if people switch the PSU on and off? Well, that's going to take much longer. Why would you do that? The PSU is like in your central room somewhere far away. Just keep that running. How about I insert the plug until it just activates there? Okay. I can still push it in that much. Okay, yeah. Okay, let's try and keep it at the edge. There. It still works. Let's wiggle it. Oh, okay. Still works. Yeah, I could look at a jumper for instant turn on when remote. No, that's not when remote detected. It's when both are detected. I need to see if I can alter the circuit so you can have an override. Talking about PSU, what if the PSU is faulty and pulses like a dodgy streetlight? Then you get a new PSU. What? Oh, I managed to wreck it. Well, it's still doing something. Okay. Did I kill it? No. Still working. Okay. I'm just gonna do this for a little bit. La 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 la. Remote detected. Remote detected. Where is it? Where is the stupid remote? This is why the hot plug protection is there, right? For people who are like, I need to get it. It's not. It doesn't fit. It's okay. Okay. But yeah, I mean, this is how this. I know you guys, and I know a lot. Some of you are going to use it like this and be like, "Oh wait, no, we need to unplug and plug it in there. It didn't fit. Is it in? I don't know. Maybe something like this. Okay. I think the protection circuits are working." Because the earlier versions of this board we blew up many times, or I did. I have a whole graveyard of boards. But it seems my new protections are pretty robust. It could be a failure of PSU, cheap Chinese one. Well, if it's a bad power supply, I'm going to need... you want me to protect for that too? How do I do that? I'm not sure what you're asking, Yummy DJ. I mean, I'll test a few like 1000 watt 55 volt power supplies, Chinese versions, but we recently tested the LRS 1248, which did go up to like 58 volts, so you could use it at 55 volts, which would be a very good candidate, or an LRS 600 would also be great. Those can also go up to 55 volt. Yeah. I mean, how often are you going to be plugging this? In theory, you just install this, put it in your wall or ceiling, and be done with it. It's still working. Okay. How about we make this more interesting? 55 volts. It is meant for 55 volt. Keep it at 55 volts. You can run it at 48 volts too. That's fine. But yeah. So how about we get a defunct... that's what I was going to say, the LED scientist. We get a defunct LED or Ethernet cable, and we cut it, and we expose the contacts, and then touch them together. I don't know. Let's see what happens. Right? Let me get some scrap Ethernet cable. Okay, this is the Ethernet cable we all have. This Ethernet cable is missing the lips on both sides. We all have one of these. Oh, interesting thing. Let's see. Let's set it to solid. There. Solid white, that's fine, whatever. Okay, what is the voltage on the input right now? Let's see if I can poke it through. Oh, I can't reach the contact. Okay, I can't reach the contact. Okay. Okay, unscrew. Yeah, the idea is that this is going to be a whole ecosystem. Right, so currently our input voltage is 52.7. Okay. So now we disconnect this puny Ethernet cable. Oh, it's a little bit warm. That's good. Oh, that's probably because of the LED strip. Okay, so let's connect this one with no lips. Okay. And now we're seeing a voltage of 53.8. Okay. So we gained about a volt because this just has larger strands inside, I imagine, right? Okay. Well, we already did all the plugging and unplugging, I guess. Yeah, it's just gonna work. Okay. So we haven't been able to kill it yet. How about we... Okay, I'll put my safety glasses on just to be sure. I'll take these. Yeah, we're gonna cut it. We're gonna cut it. Okay. So, oh, but no, wait. Yeah, this won't work because it doesn't detect the remote board, so there's no power on the cable. Okay. Yeah, okay. Right. So, I'm gonna start, but we can only do it once. Because if it doesn't detect the remote cable, it only sends 5 volt at 100 milliamps. So I mean, that's limited with a fuse. So I guess we have to make it count. How does that? What is the best way to kill it? I don't know. Do we just cut it? I guess. Use a terminal. Oh, we can use those RJ45 splitters. I don't know where they are though. I'd have to find them. Maybe. Okay, I'm just gonna cut it, and we'll see. Well, oh, I saw. Uh oh. It's activated. Okay, I'm just gonna hold it like that. Oh, damn it, my macro lens isn't on there. Hold on. Yeah, okay. All the PTCs are shorted, or enabled, basically. So we're having 3 watts of power draw. Okay, the MOSFETs aren't very hot. Okay, do I release it? Oh, we're still getting some power. Okay, well, let's turn it, uh-oh. Oh no. It broke. But I mean, I cut into the cable, so I don't know. Let's turn it off. Turn it on again. Still working. What do you mean? Okay, wiggle it. I don't know which conductors I cut. Can I see a PTC that's... No. It's pretty warm over here, but that's because the PTCs were dumping a lot of heat into the board. So that's okay. It just needs to cool down. I don't know what what I cut. Okay, let's do it again, I guess. I don't know, put this in here. Oh! It's shooting fire at me! Oh, it smells burnt. How is it still working? I mean... Yeah, the PTCs have cooled down. Okay, I'm just gonna do it again. Okay. It turned off, it turns on, and it still works. I'm surprised it's still working. I guess we didn't hit the data wires yet. Okay. Let's do it some more. More spark. Yeah. Okay. Oh! Fireworks! Oh, there. I killed it. Is it gonna come back? Is it gonna come back? Oh, it's still working. It's sparking, but it still works. Is that good or bad? I don't know. Is it drawing a lot more power? No. I have to have cut something. I mean, okay, let's take a look at what I cut. I mean, that's cut wires for sure. Is this recommended usage? Yeah, I think it's running over 1 PTC now. I'm not quite sure. I'm just gonna keep going. Ah! Holy shit! It's really mad. Okay. Did that kill it? Nope. Do we have any cables left? Is this Wi-Fi power? I don't know what's going on. I'm afraid to cut more. I like making the sparks. There. Okay, well, so there's no power now, right? Because it's shorted. So it is a safe system, right? Oh, we can actually see. If you look on this board, this one has the pair display, and there's only 2 of the 3 lit. So if I do this, there's 3 lit. So now all 3 pairs are giving power. And if I do this, there's only 2 lit. So I only cut 1 pair, I think. Oh, it seems one of the LEDs has failed. Not sure about that. Okay. But yeah, as long as the short is there, the PTCs, you know, cut off the power. I guess we're just gonna cut a bit more. Oh, yeah. Okay. Oh, okay. We still have 2 wires of power. Really? How? Yeah. Does the hot plugging still work? It will work. 1 pair is data and 3 pairs are power. So if I cut the right pairs, but of course all pairs are still energized. Oh, we were down to 1 pair. Oh, flames! I saw a flame! Oh, okay. Now we might have killed it. Let's see. Nope. That still works. Okay. There we go. That was nice. Okay. Okay, let's see what happens. Aw. I don't think we have any pairs left. Yeah. I mean, oh. Yeah, I don't think we can maybe try and push it together and see if something... Oh, there we go. Oh, yeah, wait. Hold on. I can try and mate it together. There, we have remote enabled. Output enabled. Nothing's happening. Let's see what's happening to the fuses. Oh, our drain resistor is very hot. Okay, that's not good. Oh, now our output on is on. Okay, I think we killed the sender board. Okay, let's turn off the power. Maybe? Oh, I can't turn it off here. Wait. Off. Okay. And turn it on again. Yeah. No. I don't think this is gonna work anymore. Oh, that's right. The stupid cable is still... Maybe the cable is just shorted. Okay, let's put this one away. Okay. There. Power. No. Oh, well, it still works. Let's see. Gradient. Yeah, okay. Oh, I can't close my Oh! What? I can't close my scissors anymore. My poor scissors. Come on. Yeah, oops. Okay, so it still works. Can I still disable it by disabling the power? No. Okay. The output circuit is broken. Okay, there's nothing dangerous going on. Well, now you've got your instant on-off, right? This is what you wanted, right? So it doesn't matter if it detects a remote or not. It just never turns off anymore. Is that okay? We're still getting power on all three pairs. Yeah, but I'm okay with this. I don't know what needs to happen. I guess if you deliberately go cutting into your cables. No, we're not going to submerge it in water. What? Yeah, I guess you need to deliberately, I don't know, start cutting cables and stuff like that. Yeah, if you drill into the cable, but there's protect. I mean, it did spark, okay, but then once the short, if I kept the short there with the scissors, you saw that the fuse is activated, so that was fine, and I think it only died when I held everything together. That somehow killed the positive MOSFET, so the on-off doesn't work anymore. So if I now turn off this one, the output basically always stays enabled, and that is a sign that the output switch, the positive MOSFET, died. I've seen that happen before on previous prototypes which had less protection, but we needed to do a lot to make that happen, right? I'm not worried that that's going to happen during normal usage. Yeah. And the worst thing now is that you can't turn it off anymore. You can't turn the remote off. It still works fine. It's just always on now. Yeah. I mean, you know. So we could test the buck converter reversely connected. Wait, oh, I was going to say I turned power off, but yeah. Okay. Hiding the scissors. Yeah. I mean, that we have to resort to cutting into the cable to, you know, after like 10 cuts, make it die. I think that's okay. I think I can live with that. So now we're probably going to kill this buck converter. Oh. Yeah, do I need to add a warning? Don't short circuit the cable? I mean... I'm gonna leave the LED strip connected. Can it survive? Well, it's already somewhat dead, right? I mean, it's still functional, I'd say, but it's not perfect anymore. But I mean, I have to provide warranty on these things too, so they shouldn't die too easy. Let me put on the safety glasses again. Okay. Safety glasses provided by Draadstaal nog steeds. Okay, there. I have no idea what's going to happen. Let's keep an eye on the board, I think, or on the buck. Do we want to keep an eye on the? Okay, we can do both. There. If we do it like this, I guess we can see what gets hot. We'll do it like that. Okay. 3, 2, 1, power. Remember, the enable and the delay isn't there, so it's going to be instant on. Oh, okay. What? How did the LED strip turn on? What is even happening? So is this thing hot? No, this thing is hot. So my fuses are... Yeah, my fuses are activated. Wait, did it actually drop voltage enough and now it's outputting it to the LED strip and it's working? So the input voltage is 3.5 volts because the PTCs are shorted, and the output voltage is 2.9 volts. Is this also 2.9 volts? Somehow something is working. Okay. Well, you know, my fuses are doing exactly what they should. They are blocking the power making it through. Okay, that's fine. Let's turn it off. So that's now going to cool down. Now let's connect the buck converter the right way. Is this warm? No. I mean, I can try and protect for everything, but people are going to have miswired Ethernet cables and patches and stuff like that. And I hope it'll survive. I try and make it survive, let's say it like that. But yeah, at some point it becomes a cost versus, you know. But so far, the data outputs still haven't died, and I'm pretty sure we shorted those. Yeah, don't use a crossover cable. I don't actually have any of those anymore, so I don't know. But worst case, if you short the power wires, the fuse is just going to activate. And if you short the data side is very well protected now. That's probably why it still hasn't died. Okay, I hooked it up the right way again. This has cooled down a little bit. Oh, the capacitor is very warm. Why? Okay, on. Still works. Can we do gradient? Yeah, we can do gradient. Okay. Okay. What if buck output polarity switched? What do you mean? That we just did that? Yeah, I don't have a cable to simulate that, but you can look up the pinout on the pinout page, I think, already. Oh, you mean over here? You switch outputs over here. Ah, right. These doesn't matter. These are both ground, and it's a non-isolated buck converter. So ground is ground. That's fine. Right. You mean the output over here? So to the LED strip? I'm not sure what you mean. Red, black, yellow, black. Oh. Well, something will blow up. Okay. Wait. Oh, I keep hitting the button, but nothing happens. Okay. Yeah, but I mean, if you hook it up like that, you're just stupid. But okay. Sure. Sure. I have no idea what's going to happen. Maybe the buck will melt. Maybe my caps will explode. There is no fuse in this part because this part is already fused, right? So we're going to leave the LED strip connected. All in the name of science. Yes, okay. Let's do this again, like that. The board is still pretty hot, but you'll see it warm up. Okay. Oh, I can't hit the button. Okay. On. What's... Oh. Uh-oh. Oh, wait. I know what's happening. Yeah, that's gonna kill stuff. So, the MOSFET got really hot, but this is really hot now. Oh, did it break? That diode looks very weird on the thermal camera. See that? I think that diode's broken. Yeah, okay. How much is it drawing? 76 watts. Okay. Yeah, that is within limits. Something is starting to smell, though. Oh, I might know what's going... Oh, okay, yeah, okay. Oh, smoke. We have smoke. The wires here are getting... Okay, I'm going to turn it off now. Okay. Okay, so if we look at the wires here, the ground from the input is very warm. Yeah, my board, I think one of my diodes might be broken. Oh, wait, no, that was the reflection of the diode. That was it. Sorry, this is a metal shield, so what we were looking at was the reflection of that diode. That's why it was distorted. Okay. Well, that was smoky. Might have killed the buck converter. It's a bit warm. Okay, now it's hooked up correctly again. The buck converter is still 60 something degrees. Yeah, okay. Oh, the macro lens is on. Okay, yeah. Yeah, it got really toasty in there. Whoa, look at that. My board, on the other hand, is like, okay, whatever. Let's do this. Okay. Power. Sure, why not? Okay. So it started smoking because it was still under 100 watts. So at some point it would have killed the buck converter, I think. Or the cable would have melted, I'm not sure. But it's fused at like 2.25 amps, right? And your power supply can supply that, so... You're used to 3 hours debugging something... Oh. You spend 3 hours debugging stuff that should not work, yeah? Or killing something, yeah? Exactly, Fonctionnaire. That's exactly what you should do. Yeah, I mean, the data... We still haven't killed the data somehow. That used to die really quickly. So I think my new circuits for the data is working quite well. Yeah? Okay. This LED here, I don't know if I have the wrong value or it's just dead. Send one to Philip to test it. At some point I will. But I'm not sure these are the final prototypes yet, but they're relatively close. Yeah, just the output, can't switch the output anymore because the MOSFET died. But that's okay. That's why the protections are also there. Even if the MOSFET is like fully open, as it is now, the fuses still work, right? So... there is a TVS protection on everything, so it might still... at some point it'll kill it, but yeah. Okay, cool. Right. Let's look at some black silicone sleeving. Let's put this over here. I need to find a place for this. You might die trying. Yeah, you burn down your house trying, but you can kill it. Well, I have no doubt there's ways to kill it. We already killed it a little bit, right? It's not fully functional anymore, but I'm okay with delivering this to customers. They would have to go through great lengths to try and kill it, I think. Wow, that buck converter is still hot. Okay. I mean, what do you guys think? Is this robust enough to get used by our customers, right? Yeah, what do you think? We need to make it foolproof. How? I can't. In future versions like this one, the buck converter is integrated, so you don't even have to worry about that. Okay, so let's try and unwrap this. I guess we don't need the thermal camera right now. There. Now this is 5 meters of the stuff. In hindsight, I should have ordered just a meter. I don't know. Yeah. Now I don't really know how this works, because if you look inside here, the idea is that this part is translucent, so this will radiate outward, and this is an internal diffuser, so your LED strip goes in here. But then, how? Do you just stick it into the flap or something? How do you put the LED strip in here? Do you glue it to one side, or? Thanks, Draadstal. So I'm wondering, because it needs to face up, right? No, but the bottom is open. So we can just put it in there, but then how do you get it in the right spot? Maybe you just bend this upwards and then glue it and then put it inside? I hadn't figured that out yet. Because the idea is you shoot it into this diffuser, and that then distributes it on the outside. Slide in as well, okay. Well, let me get the LED strip, because I don't even... Oh, God. I need to check if I have working LED strip. Oh, and it came with these accessories, but I don't think we'll need those. Give this one a try. Oh yeah, it has the connector. Okay, good. So let's use well, the Dig next too. We'll use some different power plugs. Sure. These should work. Yeah, the last time she did, yes. Oh, you missed it. You missed it, Papa Brown. Papa Bros, sorry. So let's use this. We did a lot of testing. Okay. let's okay, let's set it to 24 volt. Oh, can't do that. Okay. Hold on. Before I plug in the wires, let's set it to 24 volt. Yes. Good. Okay. Now we can connect these. Easy switching. Very nice. I like. Okay, good. Looking at the LED strip, only goes in the black side of the sleeve. Yeah, it goes into this part that, well, basically opens up. Why is it so dark? There. That might be a bit better. It goes into this part. Yeah. But the question is how. First, we should test this LED strip if it's actually working, because I don't know. Let me make sure it doesn't short out on itself. I think, no. Yeah, that's okay. Is this correctly wired? Yes. Where's the arrows? Oh, this is a version that didn't have arrows yet. Okay, good enough. 24 volts. Plus data. Okay. 24 volts, yes. Good. On. Now it likely won't do anything because I need to configure the output. Let's see. SK6812, BGR, W and G swap. Let's give it 100 LEDs. But this is on GPIO 4. Save. Oh, there we go. Okay. Let's turn it down a little bit. Let's do some, I don't know, gradient again. Yeah. This strip seems to work fine. Okay, let's do max power. So bright! Oh. Okay, good. Let's power it off. Nice thing is that it actually powers off the output, but I'm going to turn off the power supply too. Off. Okay. Yeah, I only put in 100 LEDs. I don't know if the rest works, but I'm only gonna try like a meter or something like that, right? So now, how do I? Okay, let's put this on my lap. And then, do I just wrangle it in here? So, we have it like that. No. Let's do a little bit like this, see if it works. Okay. I hope I don't damage the strip though. Put the strip over an aluminium profile. Interesting. Yeah, but feeding it through is going to be way harder than this. So I'm not really looking to doing that. Because it doesn't slide, right? The silicone isn't, you know, and there's nothing to slide it on because the bottom is open. So how would you slide it through? No, I'm going to do about 1 meter and then cut it. Yeah, the pigtail is at the controller side. Maybe we can force it in like this. I guess somewhat. I'm gonna disconnect the pigtail real quick. And pull it out a little bit. There. What are we not telling me? Okay. Use fish tape. Yeah, but it's open. It's not closed. How would you fish tape? You just pull the wire out through the bottom. So that doesn't make any sense. I'm getting better at it. Yeah, if it's a closed one, yes, sure. But this isn't closed, right? It came like that. A little bit more. I think we're almost there. This was, I think, 60 or 70 bucks, including shipping. So it's not cheap. I mean, the strip is also about that amount. So the combination is, yeah. Okay, I think that's enough to get a decent effect. So let's make sure it doesn't short out on itself. Now how am I gonna wrangle this on the disk? Okay, something like that. Okay. Well, okay. There. Maybe I'll hang it off the I'll hang it off the desk. Wait, hold on. Too much stuff everywhere. It's a bit unwieldy, but I think we can get a decent impression like this. Now let's make sure it really doesn't short on itself or other stuff here. Good enough, good enough. We're at 24 volt, that's good, 5 amps. Oh, this isn't pretty. Hold on, I need to move the controller to over here. There. Okay, on. Okay. Oh, we got a red spot here. So that's probably why this strip was somewhere separate. Okay. Let's see here. Let's lower the brightness. Yeah. Let's do some juggles. Okay, let's turn down the lights. Okay, higher brightness. Wow, that eats up a lot of light. I mean, hold on, let me turn off the power real quick. Okay. If I have the normal strip here too, you can see how much brighter the normal strip is versus the strip down here. Let's see, it juggles. It's like 2 or 3 times as bright. Let's see, this is full brightness. So it does eat a lot of brightness. I mean, if you look at how bright this is versus how bright this is, that is insane. Let me turn it off real quick. Okay. Is that going to be okay? Yeah. No. There. And now it should be out of frame. You can still see a bit of the glow over here. Yeah, that's wow. There is no spread on my disk. That is full brightness. I mean, the glow you see coming from over here is so much. It's 3 times as bright if it's not in there. It's nice that it's 360, right? That is good. No, it's not bright enough to be neon-like. I thought if I'd use my strip, it would be bright enough, because this takes a lot of brightness. But it's a lot of brightness. I mean, it's perfectly diffused, that's for sure. I mean, yeah. Let's see. What would be interesting? Palette. Or Pride. Yeah, this is full brightness. Oh, and you know, this is a much lower brightness. Let's see, this is about a quarter. Halfway. 3/4. Full brightness. Is the power limiter on? No, power limiter is off. But if you see how bright this is versus this thermal camera, okay, sure. But I mean, yeah, it'll. I mean, these will get really hot. So the bare strip is about 45-ish. Over here it might be even more. Yeah, 46, 48. And this, yeah, it's inside the strip, so I mean, maybe on the bottom we can see somewhat. Does it maybe matter if I push on it? Maybe. So let's try and push it in 2 spots. Are those spots brighter? A little bit, maybe. Not too much. But yeah, the diffusion, because we have 160 zones, is pretty good. I can see it a little bit, but it's basically pretty good. Let me see. Where are we on? Yeah, you can see the stepping very so slightly, right? See that? Yeah, maybe they'll die. I'm not sure. I can try and measure the output, but I can already tell you it's like a third or a fourth of the bare LEDs. And they'll get really hot. Let's try the warm white. I mean, let me. I don't want to kill it. Hold on. That should be okay-ish. If I do it like that, you can see the difference, right? Yeah, it should be doable, Alex. Others have done it before. No, I haven't thought about making my own profiles and stuff like that. I generally try to make stuff that I think can be improved or doesn't exist yet. So, yeah. Yeah, but the brightness is very striking, the difference. Hold on. No. Yeah. It kind of does away with the power output of the strip. I can't imagine if you use a normal one, which isn't as bright. I can get my meter, but I don't think we'll get any useful results. Let's give it a try. One moment, please. Right, so let's do the bare strip first. I'm just gonna point it at the thing. And this is at 100%, so let's get some measurements. Right, so we're at a very nice CRI, but illumination is 8,455. Now I need to move this away, at least somewhat, without it shorting. This is already a strip that has been somewhat shorted, so come on. Okay, let's leave that over here. Okay, solid. And now let's measure this guy. Of course, the distance doesn't match, and blah blah blah. Okay, now we're getting 314. So let me move it here again. Right, so it's over here. Same distance. Okay, okay, I'll try and make it the same distance. Hold on. Okay, over here. So for this distance we get 6,000, and now for this one, I'll just put it on there. 1,000. Okay, yeah. So we're going from 6,000 at 5 centimeters distance to literally on there. It's 1,400. So, yeah. I am not sure this is. I had a purpose in mind. I'm not quite sure this is going to be sufficient for that. because it lowers the output that much. I mean, it looks nice and uniform. Of course, the colors are blown out. Wait, why not? In real life, the colors are okay. And at full brightness, this is okay in a dark room. But anything else, yeah, it's just not going to be great, I think. Foxionaire, that might be a better solution than this, because this just diffuses too much. See, yeah, I didn't even notice that. Yeah, yeah. I mean, if you look in here, there is a lot of light, but it gets double diffused, right? So it gets through the first layer, and then it has to go through the second layer. Inside of there's a lot of light, but so let's do white. I mean, it's not that it doesn't work. It's just that it diffuses a lot. Or it dims a lot. Sorry. It also diffuses perfectly. But yeah, this is very, very, very dimmed. I mean, you can see it lighting up the whole room when it's not in there. Oh, they make lots of versions, Chris, but I was interested in this one because, well, basically it has it's not 360, but I guess 180 layer on there, right? So you can see it from all sides. Let me, there. So that's what I was interested in. I can, I guess, pull this a little bit. Yeah. Yeah, to see how that would look, and that does actually look nice. It does do that well, but you just lose so much light. Slide the LED in the top area. That actually would be interesting. Okay, I think we've seen this. Off. So let's get the strip out. I'm not going to be careful because this was already test strip. Okay, it's out. I'm just going to cut a piece because I don't know how to do that otherwise. So we're just going to cut this amount. There. Makes it a lot more wieldy. This is nice. And then I also need to cut the LED strip because otherwise I can't get it in there. I guess you could fiddle a rope through with a magnet or something, because how are you going to get a rope through 5 meters, right? Oh, sorry. Maybe you could like get a magnet and then put it in there and drag it along, and then you could put the LED strip in there. Yeah, but for now we're just gonna wing it. We need, how long do we need? We need this amount. Okay. Now I need to be careful cutting it. Okay, there. Oh yeah, I mean, I've tried this before. It's not great. Okay. I just threw some Diff-Power on the ground. Okay, it does fit. That's good. Yeah, but after a certain distance, this is going to be a problem. Okay. Yeah, I can see it on this side too, so that's good. Okay. Let's turn off the top light again. I need to turn on the power. Yeah, okay. I killed some stuff. Okay, don't mind the colors that died. Let's make it do something random. Where is it? Okay. I mean, it works, but it's certainly not as diffused as it was. Oh, compressed air could also work, yeah. Yeah, that's not great. This is on the side. But I mean the strip isn't uniformly in there, right? So it has bumps, and here you can see that it's just, yeah, how you can't fix that. Oh man, so bright. So let's try and do this method down here. Yeah, it's tough getting it in. And the longer you need to get in there, the harder it's going to be. Yeah, this method also doesn't work. I'm afraid I'm going to damage it by pushing it in, but we'll see. It's kind of stuck. Oh, I killed it. No, I killed it. It's either this IC or this IC. Let me try a different effect. Yep, no, it's dead. Yeah, this LED strip's pretty sensitive. So, now we have dead LED strip. Yeah, okay. This experiment, I call it a fail. The LED strip was a prototype, yeah. The real one is a little bit more robust, but not by much. So. Let me get the stuff off of the ground. Okay. The QuinLED COB is sensitive anyway. Yeah, yeah. Okay, well, this no longer makes any sense. Kill the power. Okay, cool. Okay. All the COB strips out there are pretty sensitive, in my opinion. They die a lot quicker than the normal stuff. So, right, secret time. I have something to show you. We can take a look at this. I'm working on various stuff, but this I haven't showed before and came in this week. And that is the most tightly packed brainboard you have ever seen. Oh, it still has the production rails on there. Those should be gone. But yeah, this is a new brainboard based on the ESP32P4. As you can see right there, it has an ESP32C6 on there for Wi-Fi. It has Ethernet. It has a USB input socket and SD card for storage, but it also has 16 megabytes of flash and 32 megabytes of memory, 2 I2C ports, 2 times USB-C, a expansion header, button outputs, power, and 8 LED outputs. And the idea is, and you can see that on this board, that if you use this top board, which I showed off before, because you can stack it on and it has a header in between the boards. If you do that on the normal brain board, you double the outputs from 8. You don't double the outputs because 8 stays 8, right? So you get 2 times 8 of the same outputs. But if you do that on this ESP32P4 based brain board, you double the outputs, so it has 8 outputs on board. And then if you put the expansion board, this top board here, if you put that on this one, you get 16 outputs. So you have one controller with 16 individual outputs. The USB-Cs are, this one's for programming the P4, this one's for programming the C6 over here, and this one is for mass storage on the P4. So if you wanted to store shows locally, you could do that on the SD card or with a USB stick, for instance. Yeah, and the idea is that in the end, I'll make different versions of this top board. This one has 8 additional outputs, but I will also, for instance, make a Diff Solo or a Diff Advanced version, where then you have, well, Diff Solo or Diff Advanced ports coming off of this top board. With the normal ESP32 board, they'll be mirrored to the local ports, and with the P4 board, they'll be individual ports. Right, but we could also do like DMX out or DMX in or stuff like that. They can, but not for the initial flash. And if I can keep it on there, so you can run various firmwares which might require different firmware levels or other stuff, I'd like to, because that just makes it versatile and you'll be able to flash it at home without a jig and JTAG interfaces and stuff like that. But yeah, this guy combined with this guy will give you 16 local outputs, and because of the ESP32P4, it'll be able to drive those with like 600 LEDs per output. So you'll easily be able to drive like 16,000 LEDs or something like that. What is it? 600 times 16? Oh, that's only like 10,000 LEDs, but still. You'll be able to drive all the ports at the same time with maximum output. Yeah, but that's the idea. If you look at this board, which I made very long ago already, this was a very early prototype for Diff-Power. In phase 2, something like this will reappear, where you put in the data inputs here, and this takes the power and then also powers the stack. And then you have the Diff-Power outputs here, which can have the remote receivers and etc. etc. Yeah, and you can have 2 of these with a P4 board to have like 16 outputs. Although I'm not sure yet on the final count of ports we'll have on the output, because since then a lot has changed and it needs a lot more circuitry for the protections and stuff like that. So it's not sure yet. This one had 8. A later one had 7. And I don't know how many I'll be able to fit in the end. Because if you look at the sender 1, there's quite a bit of circuitry on there. And I need to do that times 8. So I could potentially make the board bigger. But I'd rather keep the same form factor and then just fit on as many ports as I can. And if you need more ports, you just add more boards. Right? Yeah, I don't know. I don't think 8's gonna fit. So, right? If you look at this footprint, yeah, that's not gonna fit. Oh, the Diff-Power can do like easily 100 or 200 meters of Ethernet wiring or Cat5e wiring. And then the output is again level shifted. So after that, you could still have like 5 or 10 meters of wire or whatever. That's fine. Yeah. Yeah, but yeah, the idea is to make Dig Octa really more system. So we'll have a second brainboard type, and we'll have top expansion boards and things like that, so that you can really customize it for what you need. And the way this is done, the stacking still remains. So you could still have like the bottom board here, so that's a normal ESP32 board, then this expansion board, and you can still stack this one on top of there, and even then one on top of there if you want to, and it can all be one stack and all work together, all fine. Well, the idea is to have a large sender board, like a sender 6 or sender 8, if I can make it work. Yeah. It can be differential, or it can be local, or it can be whatever you need. You just have to buy the right boards and stack them together, and then, you know. Yeah. You do need the new version of the brainboard for that. That's not released yet, because the older ones don't have that header. And there's also a few other changes on there, but yeah. It's ONA, yes, but OS with AI. Ooh, sorry. Oh, I didn't have a lot of sleep last night. So yeah, the idea is in the end to also have a Diff-Power power board which slots into the Dig Octa system. And then you can build your stack on top of this guy, or have multiple of these, or whatever. I think an ESP32 P4 can run Doom. It has like up to 32 megabytes of memory, so... Yeah, so a lot more versatility on the Octa system. You can choose between 2 brain boards. Maybe there will be another variant of the brain boards in the future. You can choose several power boards, which we already have 4 power boards, but there will be another one for Diff-Power. And then you can choose a variant of expansion boards, which you can put on top. Yeah, that's the idea. Yeah, exactly. That's also a P4, so more than plenty of horsepower there. Okay, well, with the secret out, by the way, about this board, WLED doesn't have any software for this yet. I tested the Ethernet and Wi-Fi with ESP Home, that worked fine. There is a WLED fork from, or WLED MM fork from Troy. I still need to try that. But it did run Moonlight on there from Iwawi. And that also booted up perfectly fine. Ethernet worked, Wi-Fi worked. but I haven't tested any outputs yet and things like that. But I don't doubt those will also work. But I mainly need to test the board and stress test it. There's already a few things I want to change in regards to power circuitry and things like that. But yeah, so far so good. It has an Ethernet port, so you can do E131 DDP, whatever. Yeah. Yes, I am burning about $1,000 a month for just prototypes, I think, maybe more recently. So yeah, it's hardware development doesn't come cheap. It's a bit of both. It's the LED protocol, but it's also the ESP32. Once you go past about 2,000 LEDs, and the memory also starts to play a role. Yeah. Well, if you for instance want to have two large Diff-Power boards in the future, which each have like 6 ports, so you'd have 12 ports. Some could want that on a single controller. Yeah. Yeah, that's the idea, Jade Anderson. But I've been spending a lot, so, Thanks, Jemmy. I try to make them the best. They're not the cheapest, but they are, in my opinion, certainly the best. So, yeah. What? I greatly appreciate it. For Christmas, does that mean we on the live stream are buying the pints? The ESP32P4 has no Wi-Fi support, so that's why there is a ESP32C6 on there, and the C6 has Wi-Fi 6 support, but only on 2.4 gigahertz. But it also has Zigbee support, or Matter, whatever you want. So potentially you could write a firmware for the C6 to make it join your Zigbee network and then do Zigbee with it. Yeah, but currently as I use it, you can run something called ESP hosted on there from Espresso itself, and then it talks between the P4 and the C6, and then the P4 acts like it has Wi-Fi natively. But in the end, it's a coprocessor that handles that, basically. Yeah, but I could use a C5. Then you have 2.4 and 5 gigahertz Wi-Fi. But the C5 is very hard to get. It's more expensive, and the firmwares aren't done yet. And yeah, most use it with the C6. A BW16 for what? Nice, Jammy. I had a Mark IV Golf way back. GoFundMe, maybe, yeah. I'd rather just develop it and then sell it. My business has been running for a few years, so I don't really need the funds to develop stuff. And other people or companies, established companies which use Kickstarter, mainly do it for marketing reasons, not so much because they need the capital, in my opinion. Yeah, I'm not saying that I'll never do something like that, but generally I don't like doing that, because then, yeah. Nice, Jamie. Yeah, I had a Dutch Golf Mark IV, which was a TDI without red letters, and after that I had a Mark V with 2 red letters, so I had like 140 horsepower diesel, and yeah. I have a Passat GTE as my main car right now. I've had it for 10 years. That has like 228,000 kilometers on it now. Still like it a lot though. But yeah, working on this. I want to change stuff already, but first prototype is so far working perfectly, so that's good. Yeah. Ah, nice, Emil. Okay, well, that was a almost 3-hour live stream. Whoa. Oh no, that's okay, Greg. No worries. No worries. Yeah, so I'm gonna call it quits, and thank you all for watching and experimenting with me. We did manage to somewhat kill the defunction, the Diff-Power board, but I think the protections worked pretty good. There was no fires. There was a little bit of smoke and sparks, but you know, the protections kicked in and prevented any bigger issues, so that's good. Yeah, I'll keep working and developing on that, and hopefully somewhere this year it'll release. And until then, I hope to see you back in a next live stream or in a video or on the Discord server. Thanks for watching, guys. Bye-bye.